Today class, today I am going to discuss to you about mechanical energies. And what are these? We have three types. We have work, kinetic, and potential energies. So let's start with the work. Now on the first figure on the left, we have here a block, and then it is pulled by this applied force F over a certain distance. Now, by the mathematical definition of work, that is, work is a product of the applied force times the displacement delta x, and always note that this force is should be parallel to the delta x. So if it is perpendicular, then therefore no work is done. And then by dimensional analysis, since force is in Newton and then delta x is in meters, so we have dimension for our work in Newton meter, which is equivalent to J, stands for joules. And then work is what? This is not a vector but a scalar quantity. Even though both his components, the force and the displacement, are vectors, but since the operation of these vectors are dot product, so, and then we all know that the resultant or the resulting answer of, or the result of the dot product is always scalar. So therefore work is a scalar quantity because it is an energy. Now for kinetic energy, so as you can see on the figure in the middle, kinetic energy stands for Ki, deals with objects in motion. So if the object is in motion, of course it possesses velocity. So kinetic energy is just the product of the constant 1/2 multiplied by the mass of the object times the square of its velocity. So the massive the object, the higher the kinetic energy, and also the faster it moves, meaning it possesses high amount of kinetic energy. And then using dimensional analysis, mass is in kilogram, velocity is in meter per second, but we square its dimension, so we now have kilogram meter square per second square. And then we can separate 1 meter, so kilogram meter second squared times meter, and we all know that this one is in newtons. So therefore kinetic energy is just equal to Newton meter equivalent to joule. So same with the work, kinetic energy is also a scalar quantity. And then the last one is, we have the third type, which is known as the potential energy, abbreviated as PE. Now potential energy, we must have a reference point or a datum line. So suppose in this figure I have here a datum line, which is the floor or the ground. So this should serve as our reference frame or the datum line. And then potential energy is just the product of the mass of the object. So here we have an object, which is our book, rested on top of the table. So we have mass times the acceleration due to gravity and the h. So by this equation we can say that the potential energy is dependent on the acceleration due to gravity of the celestial body. So since we are on Earth, so our G is 9.81, but if we are on other planets, so we also have a different value for our potential energy. And the next potential energy is dependent on the height, h. So h here is the elevation, and h should be measured from the datum line towards the object. So here, since our datum line is this one, so our h here will be this. Okay, so the higher you are with respect to the datum line, meaning you possess a lot of potential energy. And then potential energy can also be zero, because potential energy should have datum line, so what if we shift our datum line? Let's say we put here another datum line. So this is datum line 2. Now, since our object is already on the datum line 2, therefore the potential energy in this case is now be 0. So therefore PE2 is equal to 0 because we don't have any elevation anymore. And then if we're going to have unit analysis, so mass is in kilogram, this is for potential energy, and acceleration due to gravity is in meter per second squared. Then the height is in meter. Now if we're going to combine this, it will transform, or this is equal to Newton times meter, so therefore that's in joules. So the same thing gihapon sila. So again, we have three mechanical energies. We have the work, which is associated with an applied force, and the force should be parallel to the displacement. And then next is kinetic energy, which is associated with velocity. And then finally we have potential energy, which is associated with the elevation and as well as the acceleration due to gravity of the celestial body. Let's go to conservation of mechanical energies. So in conservation of mechanical energies, we consider two situations. The first one is without considering friction. So meaning this is an ideal condition. So ideal, what type friction ini? And of course, di siya mahitabo in reality, because in reality we have a lot of friction and air resistance. So for the conservation of mechanical energy, the principle is the energy that is being input in the system is just equal to the energy that is being output by the system. Or in terms of states, so when we say states, mo siya ang kanang time nga mo na siya ang time nga equilibrium ang usa ka object at a particular moment. So we can also say that at state 1, the energy at state 1 is also equal to the energy at state 2, because if there are some activities that will happen, meaning nag-change na kaog state, and then the energy from one state to the other are just the same. That's why we have energy 1 is equals to energy at state 2. So in conservation of mechanical energy without considering friction, this is just energy in equals energy out, or in terms of state, that is the energy at first state is equal to the energy at the second state. Now applying this in our figure, so consider this is a roller coaster ride. Let's say our object of interest here is, or are the people that are on this car, kaning silang kaning open nga car, and then of course they are located on top of the ground, so they have some elevation. Let's say this is H1, and then we are going to determine the states. So let's consider that the state 1, or ang ilang kalagayan ba, so ang kalagayan nila diri is nasa sa babaw, so this would serve as our state 1. Then what if it will go down? So there, let's say until ari lang atong analysis, so we can also call this one as the state 2. So we now have state 1 and state 2, and by the conservation of mechanical energy, it says that the energy at state 1 is just equal to the energy at state 2. So what are the energies that are present on state 1 based on the three mechanical energies? So we have the first one is the kinetic energy 1 plus the potential energy 1 plus the mechanical work, which is equal to the kinetic energy 2 plus the potential energy 2 plus the work mechanical energy, the mechanical work 2. Okay, so as you can see right here class, all the energies from state 1 are kanang being transferred effectively. Walay labis, wala pa nagkuwang. So nga ni ka-efficient mo, kaya ideal ni siya. And then at state 1, of course, our kinetic energy here, since it possesses velocity, so we also have V1 right there. And the same thing with 2, it also has a velocity V2 because it goes downward. And then at point 2 pod, napo na siya height or elevation with respect to the ground. So here we can say that kinetic energy 1 is 1/2 mass v1 squared plus the potential energy is mgh1, or the first elevation. Let's say the car has some mechanical work, so let's just assume that we have a mechanical work at 1. Then the next one is, again, for kinetic energy, 1/2 m v2 squared, then plus we have mass times gravity times h2 plus the mechanical work at point 2. So this is now the equation for our conservation of mechanical energy. This is for ideal condition. So why friction nga present sa atong system, so wala mga air resistance. But di man gyud mahitabo sa tinuod na magid tay mga friction o air resistance. That's why in our second condition, we consider friction. So here, this is the actual condition. So actual gini siya, class. Actual condition. So for an actual condition, class, again, let us consider this one. This the same gihapon na figure. So this is our state 1. The moment nga naa pa sila sa babaw, and then state number 2, assume ta nga naa sila sa ubos. So this is state 2. Now, mas better man good, class, nga we need to identify the states first, kay maglisod man ta og asa ta mag-refer sa atong calculations. So at state 1, again, of course, it possesses some elevation. And then since it is moving, so na siya velocity pod, v1. And then at state 2, of course, it has height of h2. And then it also has a velocity of v2 because padong pa siya paubos. So nagpadong paubos, nagdagan pa na siya. It's moving. And then midway between 1 and 2, so since this is an actual condition, so it experiences some frictional force. So again, frictional force always act in opposite direction. So if the direction of motion is downward, so the friction is upward. So what are these frictions, class, in reality? So this frictional force can be experienced between the surface, between the wheels and the railings. So siguro basin taya, nagkataya na, so manang hipugong na siya. And another one is due to air resistance. So air resistance between our atmosphere and the car, and also the passengers. So that's it. And then again, same nagyapon ng principle. We're just using the energy in equals energy out, or energy at state 1 is just equal to the energy at state 2. But this time, it does not give the entire 100% of the energy 1 to the useful energies in state 2, because na may friction. So therefore, at energy 1, or energy at state 1, we have kinetic energy 1 plus potential energy 1 plus some form of mechanical work is equal to kinetic energy 2 plus potential energy 2 plus mechanical work at 2. Now, ideally, class, kung walay friction, ang tanang energy gikan sa 1 ma-convert into kinetic energy po sa 2, potential, and the mechanical work. However, due to the presence of friction, now, ma-waste na to. So, meaning, ang uban dayong energy nga gikan sa point 1 is nagamit day in order to overcome these frictions. That's why we add here the work due to friction and air resistance. So, dungan na sila. Friction and air resistance, i-combine na siya. So, therefore, dili tanang energy sa state 1 na gamit sa mga energies like kinetic energy, potential, and mechanical work sa state 2, because other energies kay nagamit in order to overcome this friction. Maning work friction. Manang ang work sa friction is included on the state 2. So, more na siya, class, meaning dili siya 100% efficient ang pag-convert sa energy from state 1 to state 2. Okay, so in order to internalize that one, so let's answer some problems. So here we have a figure and some data. So it states here that the driver of a 1,000 kilogram car traveling on the interstate at 35.0 meter per second, nearly 80 miles per hour, slams on his brakes to avoid hitting a second vehicle in front of him. So this one, the second vehicle, color in gray, which had come to rest because of congestion ahead. So traffic di ay. After the brakes are applied, a constant kinetic frictions, meaning we are in the actual condition because friction is experienced in our system. Of magnitude 8,000 Newton acts on the car. Ignore air resistance. So we don't have any air resistance, we only have friction between the tires and the road. Then at what minimum distance should the brakes be applied to avoid collision with the other vehicle? So the unknown for letter A is delta x. For letter B, if the distance between the vehicles is initially only 30 meters, at what speed would a collision occur? So at letter B, worst case scenario, because it means that the collision speed, meaning nagbangga gid ang car, kaning blue nga car o ang gray nga car. So first things first, class, again, para di umasaag, so you need to identify the states. So again, diba, when we derive the conservation of mechanical energy equation, we consider the states. So here, let's consider nga ang state 1 is kuan siya, class, before pa siya miduol sa car. So here kani siya, this is our state 1, and then state 2 is hapit gamay-gamay na gid siya, duol na gid siya, but wala siyang dasmag for letter A. This would be state 2. Okay, since we already know the states 1 and 2, so basically class ang states 1 and 2 malocate na siya at initial nga condition or initial situation, and then the state 2 is the final situation. So here, don't forget to write the given. So what are the given, class? The given, we have the mass of this blue car, which is abbreviated as M, equals 1,000 kilogram. What else? We have the velocity of the blue car equal to 35 meter per second. And then we also have the frictional force, that is FF is equal to 8,000 newtons, so very high, in order for the blue car to be stopped para di siya mabangga sa gray car. And then what else? So wala na. So let's start solving for letter A. And what is the required for letter A, class? The required here is the minimum distance, so that would be delta x in order to avoid collision. Okay, and then our field of interest here is from state 1 until state 2. So let's solve. So solution. Now in solving this, we are going to use, of course, the conservation of mechanical energy with regards to friction. So this is friction, so actual condition. So in the second situation, class, in our previous slide, we have kinetic energy 1 plus the potential energy at state 1 plus the mechanical work at state 1 is equal to the kinetic energy at state 2 plus the potential energy at point 2 plus the mechanical work at point 2 plus the work of friction. Kaya na naman tayo friction. Iyam na i-overcome kaya brake man ka, so dako kaya ang friction ini. Okay, at state 1, since nagdagan man siya, of course it has kinetic energy. But the potential energy, class, since our datum line here is the ground or the road, so this would serve as our datum line. And then in the datum line, it is also the resting place of these two cars. So therefore, we don't have any elevation. So this will make equal to 0, and also the second potential energy. And since we don't have any given for the mechanical work, so we can just ignore this one. So what's left is just the kinetic energy at point 1 is equal to the kinetic energy at point 2 plus the work due to friction. Now, ang gipangita man is the work due to friction, so we can say that for kinetic energy, that is 1/2 mv1 squared is equals to 1/2 mv2 squared plus the force due to friction multiplied by the displacement. So since this one right here is the unknown, so we can transpose it on the other side and then divide everything by ff. So that would be delta x is equals to 1/2 m then v1 squared minus v2 squared all over the frictional force F. And then diba naamantay V1. So here we have V1, which is equal to VI, which is equal to 35 meter per second. Since gingon man sa point A nga minimum distance should the brake be applied in order to avoid collision, so meaning hing stop na siya para di siya makakolide sa gray nga car. So therefore, the condition for our velocity at point 2 is equal to 0. Kay, wala naman siya nabunggo. May nakahunong siya. Okay, so this one will be 0. So, ang answer na nato diri is 1/2 times the mass. The mass of a car is 1,000 kg or 1 ton. Then multiplied by the square of the initial velocity, 35. So that would be 35 squared. Divided by the frictional force is 8,000 newtons. So, as long as considered, consistent ka sa imong units, so wala kay problema. So that is 0.5 times 1,000 times 35 squared divided by 8,000. The answer is approximately 76.56. So this one is 76.56 meters. So I think consistent man ato mga kuan ang atong mga units diri, because 1,000 is in kilogram, then this one is meters squared second squared, the velocity is squared, and the frictional force is kilogram meter per second squared. Of course, kilogram will be cancelled out, second squared will cancel out, mass cancel out, so most na mabilin, so that's why we have in meters. So therefore, this is the answer for letter A. Para di sila mabangga, mo-break na siya daan 76.56 meters away sa usa ka car. So mao na siya basically. Okay, how about for letter B? So for letter B, the question is, if the distance between the vehicles is initially 30 meters, at what speed would the collision occur? So we add some definitions here, or given the delta x of B is equal to 30 meters. Okay, so here what we are to find out is the collision speed, or the speed at point 2 for the collision, or we can just denote this one as v2 prime. So this would be equal to v2 prime. So that is the required. Then solution, again, since napagyapan na siya frictions, again the kinetic energy at state 1 plus the potential energy at state 1 plus work, mechanical work at state 1 is equals to kinetic energy at state 2 plus the potential energy at state 2 plus the mechanical work at state 2 plus the work of friction. Okay, so since wala tayo PE kay ato reference or datum line kay migo ang pala ang subject of interest. And then for key E1 and key E2, of course, naa sila'y unsa man, naba sila mga values or wala. So let's try to find out. So for key E1, that is 1/2 m v1 squared plus the mechanical work, since wala given sa problem, so ignore lang tani. So kinetic energy din habilin si Picas, so we can just equate this one. So this is equal to 1/2 mv2 squared. So si v2 squared, si v2 din na siya 0 because wala na nakastop ang car, so nag-collide na siya, so therefore natay v2 here. So then plus the frictional force ff, then multiplied by the delta x of B, that is delta x of B. And then since we're going to find the v2, so we can transpose this one on the other side. So we now have 1/2 mv2 squared is equals to 1/2 mv1 squared minus ff delta x. Now we can multiply both sides by 2/m, so that's v2 squared na mabilin. So we have v2 squared is equals to v1 squared minus 2ff delta x all over m. Then taking the square root both sides, that would be v2 squared is equals to the square root of v1 squared. What is v1? That is 35 meters. That is 35 meters squared minus 2 times the frictional force is 8,000, and the displacement, the new displacement is in 30, then divide by the mass of 1,000 kilogram. So v2 now is approximately equal to square root of 35 squared minus 2 times 8,000 times 30 divided by 1,000 divided by 1,000. The answer is square root of 745, or in decimal that is 27.29, approximately 27.29 meter per second. So this would be our answer for its collision speed during collision. Okay, so let's proceed to the second problem. We have here a diver of mass m drops from a board 10 meters above the water surface in the figure. So neglect air resistance, so we are shown that this is an ideal condition. Use conservation of mechanical energy to find his speed 5 meters above the water surface, and then find his speed as he reaches the water. So take a look at the picture, class. Kung ang tao is naadre sa babaw, class, it gains what? It gains higher potential energy, and it doesn't have any kinetic energy kaya nag-rest. However, as it dives, class, slower na po yung potential energy. Why? Because it dives downward, and then kung mag-move ta downward, mo decrease ang elevation, so therefore mo decrease si potential energy. However, si kinetic energy kaya mo increase. Why? Because of the Earth's pull, so kusog kayo mo descend ang kaning diver, so that's why its kinetic energy will also increase up to maximum. So basically and then pag abot na pod nga to sa ubos, so mag zero na pod si potential energy, and then when this diver stops, so mag zero na pod si kinetic energy. Man ang singuton to siya digha magkuan tungod kay ni transform na pod mga energies. So before that, we write first the given. So sa mga given dire. So the given here is we have the mass of the first one, m. Wala may gibutang. Then the height of the board, let's say this is our state 1. So again, I gid kalimot og butang sa state 1. State 2 is here, since importante ni siya kay mo na gipangita sa letter A nga i-find a mechanical energy at when he is 5 meters above the water. And then the last part is when he hits the water, since naman si big record nga hits the water, so we can also consider the water surface as our state or study of interest. So here our H1, we are given H1 equals 10 meters, H2 is equals to 5 meters. Of course, H3 with respect to our dotted line, that is equal to 0 because this is now our datum line. Okay, so I think na-given na tayo, no? So let's try to answer letter A. So for letter A, the requirement is find the speed of the diver 5 meters above the water. So that would be V sub 2, di ba? Ang V sub 2 kay from state 1 to state 2 ang analysis. So mo na ipangita. To do that, let's solve. So solution, since this is an ideal condition, so we can just use the conservation of energy for the first condition. So we have here kinetic energy at point 1 plus potential energy at point 1 plus the mechanical work at point 1 is equal to the kinetic energy at point 2 plus potential energy at point 2 plus the mechanical work at point 2. Since wala may given mga mechanical works, so wala ni siya. And of course, we have potential energies here because we have elevation. So what is the initial kinetic energy? So since free fall man siya, drop from ang diver from a height, so meaning wala kay initial velocity because nagpadara ka, nagpahulog ra ka. So that's why our key here is 0. And then how about potential energy? We have the value because we have mass, gravity, and we have H1 is equal to, how about kinetic energy at point 2? So ta tungod kay in the middle naman siya sa pagdive, so that would be 1/2 mass V2 squared, then plus potential energy at point 2, nagyapon siya elevation with respect to that datum line, that will be mgh2. Then we're going to solve for V2. So atong bahaton i-transfer na ito. So we now have 1/2 mv2 squared is equals to mg, that is h1 minus h2, then multiplied both sides by 2 over m, that would be v2 squared is equals to 2g h1 minus h2. Okay, and then take the square root of both sides. So square root on both sides. We now have v2 is equals to the square root of that one. Then we can just substitute the values. So g is 9.81, h1 is 10 meters minus h2 is 5 meters. And then using your calculator, that is approximately equal to square root of 2 times 9.81. Then 10 minus 5 is 5. So the resulting answer is 9.90. So V2 here is 9.90 meter per second. So mana yung velocity when at a height of 5 meters above the surface of the water. So quick review class, nabay sayop. Here divide by 2 over m. Ito i-review gamay. So 2 over m, 2g, h1 h2. And then yeah, we're good to go. So that is actually or sakto good na nga 9.90. And then let's go to the letter B. So letter B na sadta. So for letter B is find kuno the speed when he hits the water. So ang ato na po study of interest ani is from point 1 to point 3. And we are to find the speed, so that would be v3. Okay, what we need to do again, we're going to solve the problem by using the conservation of energy for mechanical energy. So wala man ni friction, so same ra gyapon, potential energy 1 plus potential kinetic energy 1 plus the mechanical work is equal to the potential energy 2 plus kinetic energy 2 plus the mechanical work 2. So here, since we consider 1 to 3, so therefore wag gyapon tay kinetic energy sa 1 tungod kay free fall man siya, then wa man gikuha ang mga mechanical work, so just ignore na lang them. And how about for, okay, sorry, this is not 2, this is 3 kay nag-iba na po itong pag-analyze sa mga states. So this one is 3, key 3, and MC is 3. So here we can just transpose PE kay ang gipangita ka in terms of kinetic energy, which is the velocity. That would be 1/2 mv3 squared is equals to mg, that is h1 minus h3. Okay, then multiply both sides by 2 over m. That would now be v3 squared is equals to 2g, then h1 minus h3. Then square root of both sides, that is v3 is equal to square root of 2 times g is 9.81. Then h1 is 10 minus 0, that is 10. Again, v3 is equals to square root of 2 times 9.81 times 10. So the answer is 14. Approximately 14.0 meter per second. So muna siya ang velocity when it hits the water. Let's proceed to the next one. So we have here a powerful grasshopper launches itself at an angle of 45 degrees above the horizontal and rises to a maximum height of 1 meter during the leap. With what speed did it leave the ground and neglect air resistance? So this one is an ideal condition. So here, this is a projectile motion for the problem, but we can solve it by using the conservation of energy equation. So I think we are given enough data for this problem. So let's consider this figure. So at the maximum height class, it was indicated here nga ang velocity component along y is 0 because it already reaches maximum sa ihang free fall nga part, but it still has velocity to move forward, which is equal to vx. And then it also has an angle between the velocity vector, initial velocity vector, and the ground. So ang gipangita is required is speed. did it leave the ground? So that would be VI, or the initial speed. Okay, in order to solve for that, so again, applying the conservation of energy for ideal condition, so that is equal to potential energy. So potential energy, we have potential energy at point 1 plus the kinetic energy at point 1 is just equal to the potential energy at point 2 plus kinetic energy at point 2. So ato na lang gi-erase ang mechanical work since wala ang gini mechanical work, especially kay grasshopper ni siya. Okay, do we have potential energy at point 1? So here mo rin itong point 1. So sorry, wala ta na consider guna. So here we have state 1. Ang grasshopper kay mao palang gipag-hop niya initial position, and then the final position is when it reaches maximum height. This will be our final position, point 2. So here our potential energy at point 1 is 0. Why? Because our datum line is the ground. Wala naman tayo lang datum line ani. So datum line. So our potential energy there, or the potential energy of our subject, which is our grasshopper, is 0. Kaya naman siya naka-stand still man siya sa datum line. How about kinetic energy? Of course, we have kinetic energy because it has initial velocity. So we can say that that is 1/2 mvi squared. How about the potential energy at state 2? So since it already achieves elevation, so that would be equal to mass gravity times h. So indicate ang maximum height is equals to h. So mgh plus kinetic energy. So since napamagyapon siya velocity, although wala lang siya velocity component sa y, we still have velocity component sa x. So that would be 1/2 mvx squared. So since this is vi and then we have vx, then we need to be consistent with our unknown variable. So take note, at state 1 class, we can draw a vector triangle, right? Remember sa itong vector discussion. So the hypotenuse is vi. We have angle here of 45 degrees. This is the velocity component along x, and this one is the velocity component along y. Now, since we are after with velocity x, so therefore we can say that velocity x is just equal to vi 45. I mean, this is cosine 45. Vx is just equal to vi cosine of 45 degrees. So we can just substitute this one directly into our equation. So that is equal to mgh plus 1/2 m, then vi squared, and then cosine squared 45 degree. Okay, so what we need to do is we're going to combine vi kaysa man anang anon, so ato ibalhin ngadto. So we now have 1/2 mvi squared minus 1/2 mvi squared, then cosine squared 45 degrees is equals to mgh. And then how about class ato ang h? Since our h is given the so at a maximum height of 1 meter, so we can say that h is 1 meter. So okay na wala problema. Then factor out vi squared, so that would be vi squared, factor out, that is 1/2 m minus 1/2 m cosine squared 45 degrees is equals to mjh. And then we can divide both sides para si vi na lang yun. That would be 1/2 m minus 1/2 m cosine squared 45 degrees. The same thing on the right. 1/2 m minus 1/2 m cosine squared 45 degrees. Cancel out. Then take the square root on both sides para matangtang ma-vi na lang. So vi is equal to the square root of mgh all over 1/2 m minus 1/2 m cosine squared 45 degrees. Now substituting the values, our m here, the mass of the grasshopper, na ba siya mass? So wala. But since common man din sa numerator, the denominator ang mass, so we can cancel this one out. Kaya kung ma-factor ni ang denominator in terms of m, ma-cancel sa numerator. So we now have g na lang. G and h, that is 9.81 multiplied by height of 1 meter divide by 1/2 minus 1/2 then cosine squared of 45 degrees. So VI now is equals to, let's simplify, that is square root of 9.81 multiplied by 1 then 0.5 minus 0.5 times the cosine of 45 squared. So the answer is 6.26. So our initial velocity pala is 6.26 meter per second. So mo rin ang initial velocity sa ato ang grasshopper. So wala by kuan, wala error. So let's try basin na error. Again, kinetic energy, potential energy, kinetic energy at point 2, gibalance siya. Nahimo siya ingani. Then gi-factor out. Okay, gi-factor out ang VI. So nahimo lang ingana. And then okay, sakto gid. So okay naman. So therefore we are good to go. So let's proceed to the next one. We have here the spring potential energy. Okay, let's consider a spring that is tied on this fixed wall. So not a spring. And then of course, kung wala na ito gilabtan, it achieve an equilibrium position. Let's say this is the equilibrium position. And then if we disturb this spring, let's say ato siya gi-pull. So mo displace na siya at a certain distance. So this is the equilibrium, so it displays x sub I. And of course we have here an applied force. Now the work for spring class, or we call this as PES, or the spring potential energy, is just equal to the integral of the force times the displacement, or delta x, because we all know that work is force times distance. Okay, but since naman characteristic ang spring force class, we cannot use directly this one. Like we can just multiply the force, the applied force of the spring, multiply its displacement. We cannot do that. We use integration. And then of course for a spring class, it has some characteristics denoted by k. So k is a spring constant. So let's integrate. So integrate. Of course, in integration we have some points, or the starting point and the ending point. So the starting is at 0, which is the equilibrium point here. Equilibrium. So nagrest ang spring ana. And then mingadto siya sa may display siya og amount x sub I, or delta I. X sub I, and then that is force, the derivative of x. But we know that for a spring class, the force is just kx dx, right? The force is just the function of the displacement x. Then since k is constant, so we can factor that one out in our integral sign. So we now have x dx. And then by power rule, sa pag-integrate, the integration of the variable is just x, then you add 1 to its exponent, and then whatever happens on the exponent, the same thing with the denominator. So that would be 1 plus 1 pod. If that is 2 plus 1, so 2 plus 1 pod, that is ubos. And then here, I mean in the denominator the class, whatever the denominator plus and one, diliin nga kung unsay nasa exponent, maupod diri sa ubos. Kung unsa ray nasa denominator, add nimo og 1, because the original is it would look like this. Let's say that is x raised to n, so that would be x raised to n plus 1 divided by in plus 1 o same die class. So sorry, same die. Kung whatever the exponent, mapunay mo ibutang sa denominator for this rule. So this one from 0 to xi. Then here we now have k over 2, and we have x squared from 0 to xi. Now simplifying this, it would look like k over 2, that is x of I squared minus 0 squared. So 0 naman na siya. So the final answer is 1/2 k x of I squared, or the displacement, or simply the general formula is 1/2 k x squared. So mo din ang spring potential energy, 1/2 k x squared. And then unsa man poy kuan ani class, if ang spring, ang mga state dahil sa spring, initially if ang spring kay gipull, it has a positive work which is equivalent to 1/2 kx squared kung nakapull siya. But if ang yang initial condition is wala siya nakapull, meaning it doesn't have any spring potential energy. So makapossess lang siya spring potential energy class kung gibira siya or gi-compress. Okay, if you compress also the spring, of course nanapog kay displacement, then you also have an energy, a spring potential energy nga na-transfer sa imong spring tungod kay imo siyang gi-compress or gi-pull. So again, positive ang itong work, or we have work if our spring already displaces from the equilibrium position. Kung wala pa siya naka-displaces, wala pa siya naka-displaced, meaning we don't have any work or potential energy for our spring. Okay, so let's have an example for spring potential energy. So here we have a block with mass of 5 kg is attached to a horizontal spring with spring constant K, and in the figure. So sorry, nawala ang figure, so ato na drawing. So here naaday tay kuan diri, natay block mass, then na spring array connected to this wall, and then this one, the mass here m. So we write here given and data, so mass is 5 kg attached to a horizontal spring with spring constant K 400 Newton meter. So K is equals to 400 Newton per meter pala. Then the surface of the block rest upon is frictionless. So frictionless na siya class, meaning ideal condition ta. So ideal at a condition. If the block is pulled out to x of I, so if this is the equilibrium point plus 0, gipull daw siya padong adto. So meaning, kung gipull siya, it already possess spring potential energy. Then x of I now is equal to 0.05 meters. So kaniyang gi-draw are x of I mo na displacement. Gibira siya padong adto. Then A, find the speed of the block when it first reaches the equilibrium point. B, find the speed when x equals to 0.025. So we have another given for letter B, so that is x of B na lang is equals to 0.025 meters. So si B is, if we're going to graph or plot the states, so since gibira man siya ari, so muna na itong state 1 class, kaning gibira siya from the equilibrium position. So this one right here, this would serve as our state 1. Our state 2 here, pwede po ta mag-graph sa letter A lang sa. So ingon man ako no kay unsay speed niya kung mobalik na po siya sa equilibrium. So this would now be our state 2. And we also have another state since namantay another requirement. So for letter B, ingon man nga unsay speed niya when x equals to 0.025. This distance here can be found between state 1 and state 2 kasi from state 1 to state 2 the measurement is 0.05. Well, for B it is only 0.025, so somewhere here day ang state 3. So somewhere in the middle na ato ang state 3. Ang C kay repeat part A daw if friction acts on the block with coefficient mu k is equal to 0.15. So therefore naptay mu k for letter C na mu k is 0.15. So pangadto na ni kay gibinat si diri, din ang motion na ni pangadto na sa wall, directly to the wall. Okay, let's try for letter A. A is find the speed of the block when it first reaches equilibrium point. So the requirement here is the speed of the block at equilibrium point. That is V of 2. Okay, at state 2 man ang atong equilibrium point. So the state to be considered is from 1 to 2. Now this is ideal condition because we neglect friction. So we can say that PE1 plus kinetic energy 1, and since nanamatay spring, we add the spring energy. So that is PES1 is equal to the PE2 then plus kinetic energy KE2, that is KE2, then plus PE2. Okay, so PE2 na siya, and then this is PS2. Okay, so at initial point, at point 1 class, of course, since this is our datum line di ay kaning surface, muna ito ang datum line. Okay, since sa atong datum line dira po nag-rest ang atong mass, ang atong block, so therefore we don't have potential energies for point 1 and 2, so we can crush this one out. How about the kinetic energy initially? Since release raman ni, meaning wala kay initial nga velocity, so KE1 is 0. Okay, so we only have spring potential energy at 1, that is equal to 1/2 K, and then that is XI squared, diba? Kay gibira man siya daan, so initially at state 1 nakaprocess na siya og spring potential energy. So we have KE2, that is 1/2 mv2 squared man ay pangita. How about the spring potential energy at point 2? So since nibalik man siya og equilibrium position, meaning wala na siya gibira at that moment. So mibalik naman siya. So therefore it does not possess spring potential energy anymore. So spring potential energy this time is 0. So unless kung wa pa siya kabot sa equilibrium position, meaning it still has potential energy. Spring potential energy. Tungod kay himbalik na magud siya at equilibrium position, may 0 na, so therefore wala kay potential, spring potential energy. So mo rin sila class. And then solving for V2, so we can just divide both sides by 1/2 m, then 1/2 m, of course makancel ang 1/2, then take the square of both sides para mag V2 na lang. So V2 is equal to the square root of, that is k x sub I squared all over m. Then plug in the values. K is 400 Newton meter. Be consistent with your dimensions or your units. X sub I is 0.05, so that is 0.05. Take note, squared na siya. Divide by the mass of the block, that is 5 kilogram. Okay, masya. So V2 now is square root of 400 multiplied by 0.05 squared divided by 5. The answer is 0.45. Approximately 0.45 meter per second. So mana ang velocity niya nang reach siya at equilibrium point. So ato lang matong diri V2 is equals to 0.45 meter per second. Okay, so let's go to letter B. So sa letter B class, ingon siya, for letter B is find the speed when x is equal to 0.025, and this condition is located on state 3. Diba sa state 3, since ang measurement niya from point of release is 0.025, so midway siya between state 1 and state 2. So here we can say, what is to find here is the speed, so that is V3 at x is equals to 0.025, that is, the analysis is between 1 hanggang 3. Okay, again, using the conservation of energy, the ideal condition, that is potential energy at point 1 plus the kinetic energy at point 1 plus the spring potential energy, that is PE pala, so sorry, this one. So this is potential energy to spring S1 is equal to this one right here is potential energy at point 3 na tayo, plus kinetic energy at point 3, plus the potential spring potential energy at point 3. So nga na siya class. Ingon ana ra ang pagkuan sa mga spring. Okay class, let's continue. So here, since ang atong object ay nakalay sa datum line, so therefore again we don't have potential energy at state 1, so this becomes 0, and the same thing with the potential energy at state 3, so 0 ni siya. And since it start from the point of release, so we don't have any initial velocity or velocity at point 1, so this becomes 0. So we only have potential spring potential energy at point 1, that is 1/2 k, then displacement of state 1 with respect sa equilibrium position sa spring, since we're talking about spring, so that is just equal to x of I squared. And then how about kinetic energy at point 3? That is 1/2 mv3 squared. How about the spring potential energy at point 3? Since our block here is wala pa siya naka-reach sa equilibrium point of the spring, so therefore it still possess some potential energies, spring potential energy. So we have now 1/2 k, and then the displacement of point 3 with respect to our equilibrium is just equal to equal to xb, di ba? xb 0.025. So put there xb and then squared. And since si v3 man ang ipangita, so we can just transpose this one on the other side. And then I think we can also multiply both sides by 2, so that para makancel ang 1/2. So i-transpose nato, multiplied by 2, what's left is mv3 squared is equal to k, then multiplied by xi squared minus xb squared. We can divide both sides by m, so take the square root. So we only have v3 is equal to the square root of, what is our k? Our k here is 400, so put there 400, then multiplied by x of I is 0.05, so 0.05 squared minus 0.025 squared, then divided by the mass of the object, that is in 5 kilogram. So simplifying, we have square root of 400 minus 0.05 squared minus 0.025 squared divided by 5. The answer is 0.387, approximately 0.387 meter per second. So ato i-compare sa itong previous, so si V2 kay 0.45, so mas paspas na ato since kay layo naman siya naabtan. So si V3 is mas gamay pa siya, 0.387 meter per second. Kay since point of release nag-start sa velocity from 0, pag nato niya ni V3 in 0.38, pag nato po niya sa equilibrium mas paspas na siya, 0.45. Let's try if na ay mga friction nga present. So again, sa friction na nga condition, mo na nagipangita for letter C. So for letter C, ingon siya nga i-repeat ang procedure sa letter A, the same ra ang given for letter A, and then na ay friction nga may act sa block. Okay, ang ato sang una nun kay ang pag solve or ang pagkuan sa conservation equation. So for letter C, again, atong gipangitaan ni kay velocity 2. Prime na siya class kay na may friction. Then atong interest ani is from 1 to 2. And then with friction. So this is not an ideal condition anymore. So solution, by the law of conservation of energy, so we have potential energy at point 1 plus kinetic energy at point 1 plus the spring potential energy at point 1 is equals to the potential energy at point 2 plus the kinetic energy at point 2 plus the spring potential energy at point 2 plus the work of friction na siya. Okay, we now have friction, which is dynamic friction because it is in motion na. So here again we don't have potential energy because the object lie on the datum line. The initial kinetic energy is wala kaya starts man siya from the point of release. How about the spring potential energy at point 1? We have that one because that is equal to 1/2 mx sub I squared. How about kinetic energy at point 2? So we have 1/2 mv2 prime na takwas. Okay, with friction man ni. Plus, how about the potential energy at point 2? So since point 2 is located on the equilibrium position of the spring, so therefore it does not have any spring potential energy anymore. Plus the work of friction. What is this work of friction, class? That is just equal to 1/2. Here, copy sa na to. That is plus the frictional force multiplied by the distance. And what is that distance? Of course, kinesia from 1 to 2. And then that displacement is just equal to x sub I. Diba? X sub I na siya. Okay. So we can just transpose this towards the right. We now have 1/2 mv2 prime is equals to 1/2 mxi squared minus the frictional force. This one is x sub I na siya. Okay, same na sila og annotation. Fx then x sub I. So since wala kay bawa ni f of x, again for frictional force, ff there is equal to mu k, since this is siya dynamic friction, then again the normal force. And again, ang nga tong normal force, if we're going to resolve the forces vertically, diba, the normal force is the force that acts perpendicular to the surface where the object rests. So mo na ang normal force nini, which is equal to the weight of the object by free body diagram. So that is just equal to mu k then mass times the gravity. Substituting that one in our equation, then we can also multiply directly na lang 2 over m, so that it will make to v2 prime squared plane. So v2 prime squared plane is equal to may mo na siyang x sub I squared, and then minus, this is not sorry, for spring potential energy kani siya k na siya. This is k, and then of course this one is k. So kani siya mahimo na siya og 2k over m. Wala day k, sorry, k na cancel na. So that is k over m x sub I minus we have 2 mu k, then wala na po yung m kaya makancel naman, kaya multiply ng tag m ari, so g na lang, g then x sub I all over sa paman, so wala na, so we can square both sides para ma-cancel siya. So we now have v, okay, sorry, ito erase nagbalik. So we now have v2 prime is equals to the square root of k over m xi squared minus 2 mu kg x sub I. Then substituting values, k is our k here is again 400, so we have 400 divided by the mass is 5 kilogram. Our x sub I is 0.05, so we have 0.05 squared minus 2, our mu is 0.15. Then the next one is g is 9.81, then x sub I is 0.05. okay, okay ra? So the final answer is square root of 400 divided by 5 multiplied by 0.05 squared minus 2 times 0.15 times 9.81 times 0.05. The answer is 0.23. So approximately 0.23 meter per second. So let's review daw. So frictional force daw, friction acts on the block with coefficient of 0.15. So quick review. If naabay na kuan. So again, mu kmg minus this one is x sub I so k x sub I minus frictional force x sub I, then k over m v2 this the square root, then as po nato square root of 400 divided by 5, then 0.05 squared minus 2 times 0.15 times 9.81 times 0.05. So our answer is approximately 0.23 meters per second. So as you can see, class, comparing our results from our previous nga mga nakuha, so si kuan kanide atong butang si mag-erista. Sa atay butang si V2 prime. So si V2 prime that has friction, nahimo lang siya 0.23 meters per second. So may gamay siya. This is due to friction. Tungod sa friction, iyan na siyang ki-overcome. Mao nang hingamay na iyang velocity. From the ideal one, which is 0.45 meter per second, nahimo lang siyang 0.23 meter per second. So thank you for listening and watching po.